Okay, this segment's going to be discussing brain waves. So different bandwidths of EEG activity are signifying different types of brain activity, and this is what we're going to be talking about in this segment. So one aspect of brain activity that you're receiving at the EEG level is the degree to which the brain waves are synchronized. So when they are synchronized, you can get some distinguishable EEG waves. They'll be more rhythmic, and it indicates some coordinated neural networks. And we'll talk actually a little bit in a minute more about that. So this is a graph that's typically seen. I'm going to make sure this is visible. You often have seen this in different classes, probably. The different brain waves. There's alpha, beta, theta, and delta. And it lays out the frequencies. So different degree of frequency indicates the different brain waves, and their amplitudes. And these are the four basic rhythms that you'll see. They're associated with different states, which we'll talk about. What is useful to me, and what is typically more telling in the EEG record, is the frequency. And as you see, alpha, beta, delta, theta have different frequencies that aren't really in chronological order by frequency. And so I'm going to flip this around. I find it much more helpful to look at the graph this way because frequency is the more important thing than the alphabetized order of the letters. I prefer to look at it this way, and now we're in increasing amounts of frequency as we go. And then the amplitude kind of varies across these. So this doesn't necessarily, amplitude doesn't increase in the same sequence that frequency does. So the different EEG waveforms, this is a way of looking at them. Alpha typically has some synchronization to the signal, so you can actually make out actual cycles here. And it also has higher amplitude, so again they look taller, and they're a little more stretched out than the beta. The beta is this very high frequency, where they're kind of smooshed together. And then as we go down, theta gets stretched out a little bit more, and delta gets stretched out yet the most. So the more stretched out it is, the lower frequency we're seeing. It's completing one cycle in a longer amount of time. So there's fewer cycles within that amount of time. Frequency is how many cycles within a certain amount of time there is. So as we stretch it out, that's lower frequency. So delta is the lowest frequency. These tend to correspond with different states of awareness as well. So starting with beta, this is our highest level of awareness. We're fully awake. We're maybe exerting ourselves mentally. Our eyes are open and we're alert to the outside world. Something that's important to recognize here is while it is a very low amplitude, much lower than alpha, what's happening here is the different waveforms are canceling each other out. There's a ton of waves. Again, it's all aggregated at the scalp level, what is going on among millions of neurons within the brain. And so they're canceling each other out. And so it appears to be a very low amplitude. Don't mistake that for a low level of awareness or a low level of activity. It's just that the positives and negatives are canceling each other out once at the level of the scalp where we're measuring it. Beta can also be seen, beta waves can also be seen during rapid eye movement segments of sleep stages. It has that lower amplitude than alpha, but it doesn't mean it's lower level of awareness. So alpha waves are typically seen when somebody is awake but relaxed. A very easy way to draw somebody into alpha is to have them close their eyes. That typically invokes alpha state. Okay, I said that. Amplitude of the alpha can then be diminished when the eyes are open. So this is often called alpha block. If somebody's in alpha, you've got their eyes closed, you're measuring something you're going to do in the lab in this module, and then you're required to open your eyes, and all of a sudden alpha is blocked. You revert to beta activity because you're suddenly alert and aware of your surroundings again. Okay, alpha amplitude can also be diminished when somebody is attending to external stimuli, so or with sleep. So if somebody has their eyes closed and they're in alpha, and obviously eyes open would block it, but maybe forcing them to attend to an external stimuli, auditory stimuli, can also draw them out of alpha. So the alpha amplitude in the signal is greatest from the occipital lobe, which is associated with vision, and the parietal lobes, which is associated with a lot of the other sensory areas. So in the lab, another way to invoke alpha is hyperventilation. So you'll be, the lab typically requires this hyperventilation to get yourself into this alpha mode. It increases the electrical activity and creates a higher alpha amplitude. So higher amplitudes of alpha can also be associated with when somebody is less alert, less oriented to external stimuli. Higher frequency of alpha can be associated with the speed of memory. And alpha power can increase with the difficulty of a mental task. Okay, now delta and theta. These are the lower frequency waves where they're more stretched, they look more stretched out, and they're mostly seen in stages of sleep. So the sleep stages kind of kick in with theta and then on into delta. So they increase with deeper sleep. Delta specifically is associated with slow wave sleep. This is going to be a little bit of a tie-in with Dr. Friedman's class. You'll be studying a lot about slow wave sleep in the class. And theta is a little bit of this relaxed meditative state. It can be in a drowsy kind of entry into sleep stage, or just in a very drowsy stage otherwise. Okay, so just taking a step back, what is EEG used for? It's used in sleep studies all the time. This is, it's an excellent tool because it has that degree of temporal resolution. It allows you to have a very clear sense of where somebody is in their sleep stages. It's also used in different emotional states as well. There's different degrees of or combinations of wave patterns that can be seen in different emotional states, similar for psychological states and traits. It's also used for diagnosing things like epilepsy or sleep disorders. It's also used sometimes in studying different disorders of the brain or brain injuries that have happened. If a certain part of the brain, when it should be fully awake, is showing a lot of delta activity, it's suggesting it's offline, and that can be a way of diagnosing a certain disorder that's tied to a brain injury or some sort of brain disorder. If that part of the brain is offline or in delta when it really should be in beta, that's an indication that something needs to be looked at there.